When referring to two solutions separated by a selectively permeable membrane, there are three different terms that you've got to keep in mind. The first one is hypertonic. You've got the outer solution and you've got the solution inside the cell, and it's separated by the cell membrane. That is the selectively permeable membrane. If you look at the solution, it's hypertonic. There's a lot more solute particles outside the cell than inside the cell. If you'll think about it this way, water is attracted to these solute particles. So what's going to happen is water inside the cell is going to rush outward. It's attracted to all of these solute particles. And that cell is therefore going to shrink or crenate. For the second solution, it's hypotonic. There's fewer solute particles outside the cell than inside the cell. Once again, think about it that water is attracted to the solute particles. So water outside the cell is going to be attracted and come inward into the cell. That's going to cause the cell to blow up like a balloon. It's going to, a lot of times, rupture or lyse. And then the very last solution is an isotonic solution. You've got the same concentration outside the cell as inside the cell. So you're going to have an equal flow of water into the cell and out of the cell. It's sort of a equilibrium. You can think of it that way. Alright, this lab is for the diffusion of molecules through a selectively permeable membrane. So what you're going to do, you're going to prepare a dialysis bag with the initial solution. And what you're going to do, in one end of it, you are simply going to tie a knot. Just like this. Then you're going to roll the opposite end of the bag between your fingers until it opens. Just like this. Then you're going to add 4 pipettes full of 30% glucose into the bag. Now you're going to hold the bag closed and mix its contents, and you're going to record the color in Table 1 of the results section of your lab manual. Then you're going to carefully rinse the outside of the bag with tap water. Now, you're going to add 300 milliliters of water to the beaker. Make sure the dialysis bag has the open end hanging on the outside of the beaker. Now you're going to add several drops of iodine solution to the water until it is visibly a yellow-amber color. Be careful and do not allow the liquid to spill out of the bag. If it's too full, remove some of the liquid and rinse the outside of the bag again. You're going to leave the bag in the beaker for 30 minutes. After 30 minutes, carefully remove the bag and stand it in a dry beaker. In Table 1, the final color of the solution of the bag should be recorded. Now you're going to perform a Benedict's test for the purpose of detecting the presence of sugar in the solutions. The first one is the control, and you're going to put one pipette full of water in the control tube. In the next test tube, you're going to add one pipette full of solution from the bag. This is the tube that's labeled the bag tube. And then you're going to put one pipette full of the original beaker solution in the tube that's labeled beaker tube. Then you're going to add one drop of Benedict's solution to each test tube. After heating the test tubes in a boiling bath water for 3 minutes, you're then going to record your results in Table 1 of your lab manual.